Okay, hello guys. Today is day 2 of my COP21 vlogs. So today I'm going to talk about the science of climate change. So I think a good place to start is, what is climate change? And I think you guys basically know what it is, but I want to, let's start from somewhere. So climate is, and this is, you might be thinking, why am I defining climate? But this is actually an important distinction which a lot of the climate science deniers get wrong in their arguments. Climate is basically the average, the general weather conditions in a certain area. So it isn't if it snowed today or it was sunny today. It was the general, is it generally hot and dry here? Is it generally cool and wet here? So that's what climate means. And climate change is whenever the climate changes. Pretty simple. And it's not like the climate's never changed before. The climate has been changing ever since we've had an atmosphere to host a climate. It's just that the climate change which is happening now is very different, and we'll get into some reasons why in a minute. So when we're talking about climate change right now, we're talking about human-caused climate change, which is happening right now, and we're talking about it's global warming. And let me mention that this is a global, let me emphasize global. It's the globe. It isn't about any specific one place. It doesn't mean that one specific place is going to get hotter. It's just an overall warming of the Earth's climate. Now, what is causing this? You probably know this. It's greenhouse gases, primarily CO2, but other chemicals do it as well. So CO2 and these other gases are called greenhouse gases. And effectively what they do is that they trap heat from the sun. They act in such a way where when the sun sends heat in the form of radiation, light, towards Earth, it passes through the atmosphere, it passes through the greenhouse gases. But then it hits the Earth. Some of it is absorbed by the Earth, but a lot of it is reflected back up. Now usually most of this radiation would go into space, not all of it, because the atmosphere has to stay warm. But a lot of it would go into space, and some of it would be absorbed in the atmosphere. Now, there's something about carbon dioxide and these other greenhouse gases which makes them make the atmosphere absorb all of that heat. So it's almost as if someone placed a blanket around the Earth. It's keeping in all the warmth, and it's making it hotter and hotter and hotter. Now, something which climate skeptics might point out, and this is even a question which I've had until I found this article, which I'll link to in the description, is how do you know that carbon and carbon dioxide absorb heat, and this type of heat? Well, it's actually written into the chemistry and the physics of carbon. So let's begin with light, which is what's sending this energy, this heat. Light is a wave, at least for our purposes. Let me not get into quantum mechanics. So light is a wave, and waves have all sorts of properties. They have wavelength, which is a distance between a peak and a peak, or a trough and a trough. So basically, the distance from one point of a certain intensity to another point of a certain intensity. It has frequency, which is how many of these wavelengths pass in a certain amount of time. So there's all sorts of things you can measure. And light can come in any of these kinds of frequencies or wavelengths, and the collection of all these is called the electromagnetic spectrum, and I think I have a picture somewhere here if I add it in post. So, most of the light which the sun emits is visible light. Visible light is the only wavelengths which our eyes can detect, which is why it's called visible light. Almost 50% of the light which the sun emits is visible light. So this comes to the Earth, and it goes through our atmosphere, and it comes to the Earth, and it's kind of absorbed. Now, something to point out here is that there's been studies in thermodynamics and physics in general about blackbody radiation. And the idea behind blackbody radiation is, well, this isn't really it, but I'm going to really simplify it here to really get at the bones of it, is that when you change the temperature of an object, how does the light which comes from that object change? So when you have cooler objects, then you will have longer wavelengths. You'll have less energy light. And if you have higher wavelengths, if you have a higher temperature, then you'll have higher wavelengths. Kind of makes sense intuitively, right? Now the Earth is obviously much, much cooler than the Sun, because the Sun's a star. So because of that, the light which the Earth emits back up, which it reflects, is actually infrared light. It's a bigger wavelength. Now, excuse me. Now, if you look at carbon is an element, and all elements have their own characteristic atoms, and something about the atom will explain basically every property of that element. Now, one thing which atoms do is they absorb light, and that light can then be converted into energy. And the way this happens is that atoms won't absorb any kind of light. They can only absorb light of a very certain frequency or wavelength. So they usually have their own specific threshold, and then they can absorb that light. It turns out that the threshold for carbon is not at visible light, but at infrared light. So what that means is that when the visible light goes through the atmosphere, it doesn't affect the carbon because it isn't at the right threshold. It doesn't absorb it at all. But then when the Earth reflects it back up, since it's now turned into a lower wavelength, it can absorb it. So it absorbs the light, and because of that, it absorbs the energy. So I think that's a kind of cool clarification which I wanted to point out. Okay, so here is our theory of global warming. Now, people will say, prove it. It has been proven, and I want to give you an overview of some of the definitive proof which we have found. First of all, if we want to test our theory, then we want to find some definitive predictions which our theory would produce, which we could test effectively. One of these things is that less heat should be escaping to space. Because remember what we said, in a normal system, the visible light, all of the light from the sun would be coming to the Earth. It would go through the atmosphere. Some of it would be absorbed, some of it would go on, and it would hit the Earth. Some would be absorbed, some would be reflected back into space, while some would still be absorbed by the atmosphere, of course. Now, because of the CO2, the greenhouse gases, trapping some of that heat, that means that less of that heat should be going into space. And satellites have measured that, so that is definitely a fact. We've also found more heat returning to the Earth, both in terms of statistics. For example, the popular saying, which you probably have heard, that 10 of the warmest years ever recorded have occurred since 1998. And I think this is 10 out of the 11 or something. I don't remember my facts specifically. But we know that the years where we've had a ton of carbon dioxide emissions were definitely more hotter. And on top of that, we've actually received more infrared waves, which, remember, are the waves which the Earth should be sending back up into space. Some other evidence. So we know that there's this heat factor. Now, do we know that this is the carbon? We do know that there's more fossil fuel carbon in the air and more fossil fuel carbon in the ocean. Now, to really drive this home, I'll have two graphs here. The first one will show carbon dioxide emissions throughout the years. So hopefully it's somewhere here. I don't know how I figured it out in editing. But you can see that over the years it's gone up, and over the last couple of years it's gone up massively. Now, and this really nails it. This is a graph of the temperature change from normal. So you'll see on the y-axis it has +5 degrees centigrade plus stuff and some minus stuff. So when it's +5, that means that it's plus 5 degrees, for example, over the normal. And this is plotted throughout the years. And you can see that it's almost exponential. And if you look at both graphs, you can see that they probably start in similar areas. So not only do we have the causation brought by our theories, we have correlation. So these are the facts. What else do you want? Okay, there's other stuff. There's a cooling upper atmosphere. So the carbon which we're pumping into the air, it only goes so high, it doesn't go all the way high up. So what that means is that since all the carbon in the lower atmosphere is trapping everything, the upper atmosphere should be cooling. We do see that. We see a shrinking upper atmosphere. We see more fossil fuel carbon in the coral. We see that winter is warming faster than the summer. There's the major problem of ocean acidification, where because of all this carbon in the atmosphere, the ocean kind of absorbs that and it changes the pH of the water, which is killing wildlife. I don't know what more facts you need there. How about some more stuff? 97% of published papers in the climate agreed that climate change is real and is being caused by humans. Every major scientific institution, the Royal Society, the UN Panel on Climate Change, universities from all over the world, they all agree climate change is happening. Seems like the only place where there seems to be a debate is in the hearts of people who don't want to believe, and in the brains of people who would benefit more if it weren't true. Okay, so now that we've hopefully established that climate change is real, let's talk about its effects. Now, as I've said before, the climate has been changing ever since there's been an atmosphere for the climate to change on. So you might say, oh, the climate's changing. It's changed before, what's the big deal? Well, here's the main thing. The changes in climate which we saw before were all natural, and they took thousands of years, as most things on Earth do, a really long time. What we're seeing now is that we're having the same temperature change over 100 years. Something which would take thousands of years has only taken 100 years now. And we can see that's only going to get worse. Look at those two graphs which I showed you. So clearly we have a problem, but just how drastic is it? There was a report by the IPCC, which is, I think it's the Intergovernmental Panel on Climate Change. It's like the UN's investigative panel on what's happening in climate change. There's a report, and it was covered in The Guardian, and it says, the report from the UN's Intergovernmental Panel on Climate Change concluded that climate change was already having effects in real time, melting sea ice and thawing permafrost in the Arctic, killing off coral reefs in the oceans, and leading to heat waves, heavy rains, and mega disasters. And the worst was yet to come. Climate change posed a threat to global food stocks and to human security, the Blockbuster report said. Rajendra Pachauri, who is the chair of the IPCC, said that nobody on this planet is going to be untouched by the impacts of climate change. That's big, but let me break it down for you. One of the biggest impacts, which I'm sure everyone's heard of, is that it's going to raise the sea level. What we're already seeing is that the ice caps in the north and the south are melting. And because of this, there's more water in the oceans, and this is causing it to go up. Like, this is common sense. If you have a cup of water and you pour more water into it, it will go up. By the way, check out Burn Notice in the description below. But there are other effects too. One of the ones which not really too many people talk about, but which is really important, is the effect it will have on the oceans. I've already mentioned ocean acidification before, and this has already resulted in the deaths of so many coral reefs and so much wildlife. But On top of that, we're also seeing that the temperature of the ocean is rising a lot too, and this is killing even more. And the worst part about this is that the ocean has the ocean currents, and the ocean currents and the temperature which they bring have a large impact on the weather all across the world. You have the air currents, of course, but most of the temperature movement around the world is caused by ocean currents. Famous example is El Nino, and I think I'll have a link to a video by El Nino below because I just want to outsource that right now. So, and also, the ocean is kind of the heart of the world, and 80% of people, no, I think it was like, 4/5, 80% of people live near the coast. And the ocean is just such a big part of the biosphere that if the oceans aren't saved, then nothing's safe. We're seeing other effects too. Because of the higher temperatures, we're having heat waves, and we're having droughts because there's less water. Less water means worse agriculture. We're not able to produce as much food on top of such a booming population. So it's even worse. And there are several studies which predict that if climate change continues, then we'll have more war and violence. So none of this is good already, and I think this was the most shocking thing for me. A study has found that every year already 300,000 people die because of direct effects of climate change, whether it be disasters because of it, or like also whatever can be directly traced to climate change. I believe that in that same year the deaths from terrorism were like 30,000 or something. So an order of magnitude bigger. I'm not saying that terrorism isn't a huge problem. It is a huge problem. But when people say that we have much more urgent things to worry about, that is not true. And the study predicts that by 2030, which if you think about it is not far away, that number will rise to 500,000 deaths a year. So that is definitely something to keep in mind. There are effects, and we just have to be prepared to face it, and that's such a hard thing. Even though climate change is happening pretty fast, 100 years compared to 1,000 years, 100 years is still a long time for a human. And because the climate is changing so slowly, we tend to ignore it. And because it's something big, the whole planet changing, we tend to ignore it. So I think that's one of the main problems, and we have to do things now. There's a study which shows, there's multiple studies which show that if the temperature change goes beyond 2 to 3 degrees Celsius above what they should be normally, then that's when we're going to have even worse impacts than what we're having now. So we have to do things, but things aren't being done as much as we would hope to. We're having things like COP21, which is why I'm making these vlogs, and something which I'm going to get into more depth, of course, later. But we have reasons why we don't do more, and that is going to be the subject of my next vlog. So that concludes this section on the science of climate change. Thanks for watching.